Good evening, everybody. Welcome to our Algebra 2 Flip class. Our first set of video notes is covering section 2.1, transformations of quadratic functions. Make sure you pause this video right now and have your note sheet or notebook paper and graph paper so that you have everything you need to continue. Vertex form of quadratic functions. Quadratic functions are functions that have a highest exponent of x squared. Probably remember doing factoring last year or the year before. Quadratic functions' basic shape is a parabola or a U. Vertex form of these functions, a x minus h squared plus k. A is a stretch or a shrink. H is the x value of the vertex, opposite of whatever sign is given, and k is the y value of the vertex. So when we graph those then, hk is the vertex, and the vertex is down here. Let's take this back just a little bit and talk about a 5-point graph. So our quadratic parent function is f of x is equal to x squared. If I make an xy table for x squared, I'm going to pick -2, -1, 0, 1, and 2. -2, remember we're plugging those values into our function. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. We have 5 points right here. These are ordered pairs. These are the ordered pairs that we'll use to graph our parent function, and these will always be the ordered pairs of our parent function. The parent function means that it's the basic graph before we've done any stretching, shrinking, sliding to the left, sliding to the right, sliding up, sliding down, and reflections. So our very basic function. I'm going to go ahead and sketch my graph. So I have -4, 4, 4. Change my color here for some Basha green. And then plot my points. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And here is our parent quadratic function. So let's go back to now our vertex form. And for now, our vertex form that we're going to focus on is the x minus h squared plus k. This value here, the h, is going to be our left or right shift. This value, k, is going to be our up or down shift. And remember, our left or right shift is always going to be opposite of this sign. And we'll talk more about why that is tomorrow in class. So let's start with just labeling what happened to each of our parent functions. Now remember, our parent function was x squared. So in number 1, this is our shift to the right or left. Now it says plus 4, which means it really went minus 4 or negative 4, which makes that left 4. This one on the outside is our k value. That's the up or down. And -1 or -1 is a down. That's face value. So this went down 1. In number 2, we have this right here inside, which is our h value. So again, from our parent function of x squared, we went opposite of -3. So we really went +3, which makes that a right 3. So we're sliding our parabola to the right 3. And then there's nothing added or subtracted out on the outside. So we have no up or down. Number 3, we have -2 inside. That's our h. That's our left and right shift. Because again, we go opposite of what it tells us. It says -2, so it really went +2, which means we're going right 2. Outside here is our up or down. That's -2, so we went down 1. Number 4, we have x plus 5 on the inside. Plus 5, remember we're talking about opposite, so we really are going -5, which is left 5. And this +1 is our up or down. It's +1, so we're going up 1. Now that we know what our graph is doing, our parabola, we can also say that this left 4, down 1 moves our vertex. So as we start graphing, we're going to talk about that and include our vertex. So go ahead and take a look at your graph paper, have this on the side, and we're going to make our graphs. Number 1, we said we took our parent function of x squared and we moved it left 4, down 1. We have our basic graph. We're keeping with that parent function graph, which is this set of xy ordered pairs. All right, I'm going to put my parent function in green. So that's here. We have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. This is our parent function. And I'm just going to lightly sketch this graph. I'm going to change colors. And remember, we're shifting our graph to the left 4 and down 1. So I take each point, and I'm going to start with this point right up here, and hop over left 4. So 1, 2, 3, 4, and down 1. And that puts me right here at -6, 3. Then I'm going to take this point right here, slide it 1, 2, 3, 4, 1, and that puts it over here at -5, 0. I'm going to take my vertex right here, that 0, 0, slide it 1, 2, 3, 4, down 1, and there's my vertex. Take my next ordered pair at 1, 1, 1, 2, 3, 4, down 1, and then this last one over on the upper right, 1, 2, 3, 4, down 1. And so this is my new parabola. Remember, our vertex is right here. It's this lowest point for right now. Where is our vertex at? Our vertex is at -4, -1, which, when we look at left 4, down 1, or the fact that this was actually -4 with the -1, that's how we call this vertex form, because that same vertex is found right here in our equation. Let's try another one. Let's do number 2. Number 2, we said, was going right 3. And that was it, only right 3. There was nothing outside here that we were adding or subtracting, so we aren't going anywhere up or down. Graph your parent function again. Oops. I'm again going to use my bash of green to plot those original points. And sketch that original parent function graph. So now I'm going to take purple this time and slide every single point to the right 3. So I'm going to start over here, 1, 2, 3. Down here, 1, 2, 3. At the vertex, 1, 2, 3. Next point, we have 1, 2, 3, and then up here, 3, and this in purple is our new parabola with our new points that slid right 3. Again, this point down here is our vertex, and this ordered pair is +3, 0, which again we see from up here, we went right 3, so that's a +3, and we had nothing added or subtracted over here, and nothing is 0. So it gave us our vertex at 3, 0. For Monday, next class, these two problems, 3 and 4, would like you to try on your graph paper. Graph the transformation. Tell us what happened to it. Did it go right, left, up, down? And also give us that new vertex. Have a great night.